Hi, introducing our members. Firstly, we have HANI NABILA binti ABD HALIM, Raja Nur ATHIRAH binti Raja Muhammad FARID, SHAH HANIF NAZMI bin SHAH RUMIZAM, and the last one, HAIKEL SYAZWAN bin MAHAMAD AJAMAAIN.
Introductions of cryptography. What is actually cryptography means? Cryptography is the studies of encoding and decoding secret message. Code are called cipher, uncoded message are called plain text, and coded message are called ciphertext. The process of convert a plain text to a ciphertext is called enciphering, which is also we call it as encoding. And the process of converting a ciphertext to a plain text is called deciphering. Also we call it as decoding. Our project is applying the cryptography in a Telegram application. The purpose of the study in this project is to discover method of implementing linear algebra in a real life. This method is applied in Telegram to make sure the message from sender to receiver was safe. This is the way how to prevent any data detection from a scammer.
Assalamualaikum warahmatullahi wabarakatuh. And now I will be continuing with the types of algorithm. Here we have two of the most common algorithm used in cryptography. The first is symmetric algorithm, where both encoding and decoding process use the same cipher key. And then the second one is the asymmetric algorithm, where we have two keys, which is the public key for encoding the plain text into ciphertext, and also the private key which used to decode the ciphertext into plain text.
Next, moving on to the methodology. How we want to solve this kind of cryptography application according to the step-by-step. Which is the first process, we need to change the plain text to the encryption, ciphertext, description, and back to the plain text. First and foremost, the plain text of XYZ will be converted into a metric form and label it as a metric R. Next, we need to create any 3x3 matrix as a key metric, or maybe we can call it as cipher metric, and label it as metric A. And the last one is apply the metric multiplication method to encrypt the plain text, which is we multiply the metric A with R.
So the first step here is find the determinant. Basically, for a 3x3 matrix, it is found by multiplying the top left entry by determinant of the 2x2 matrix formed by the entry that are not in the same row or column as the entries. Similar steps are done with the two element in the top row, and the middle value is subtracted from the sum of others two, as shown as the table here. Step 2 is find adjoint. The adjugate matrix is a matrix of the same size as the original for a 3x3 matrix. This process is somewhat more complex than it was for a 2x2 matrix. It requires us to calculate 9 lots of 2x2 determinant and assign them with the correct sign and put them in the correct place. The example for this calculation is given here. Step 3. Inverse the key metric. To get the inverse key metric, we multiply the inverse determinant from step 1 by each of the element of the adjugate metric from step 2. Finally, we have the inverse key metric. To decrypt the message, we will use the inverse of key metric, which is A inverse, and multiply with the encrypt message, which is M, and then we will get metric R, which is the original message. From that, we can retrieve our plain text of XYZ.
Next, we will move to the results and discussion part. Firstly, we will encrypt the code using method of Hill cipher. We use the modulus 27 for the numerical alphabet. For the first step, we have to obtain a cipher matrix that's also called key matrix. Secondly, we use the following text, love, mat. We have to replace the letter by its numerical letter. Love math, when we define in modulus 27, we will get 12, 15, 22, 5, 27, 13, 1, 20, and 8. For the fourth step, we have to separate the plain text into 3 by 1 matrix. We will get 12, 15, 22 for the first matrix. For the second matrix, we will get 5, 27, 13, and the third matrix, we got 1, 20, and 8. For the fifth step, we have to augment the plain text matrix. We'll get 12, 15, 22, 5, 27, 13, 1, 20, and 8. Next, we will apply the matrix multiplication method to form encrypted matrix. This is very important to get the encrypted matrix. After we multiplication, we will get the newly formed matrix that contain cipher matrix. It is 41, 10, -5, 4, 8, 11, -3, 7, and 6. And then, we will encrypt it by the modulus 27. This calculation is when the x is positive and greater and equal to 27, we will divide by 27, and the answer we will take the one significant value and will times with 27, and we get the y value. And then after that x value will minus with y, and we will get the mod 27. If the answer is negative, we will add with 27 and we will get the mod 27. And then after that, we have to translate the matrix according to the mod 27 table.
And now moving on to the decryption process. Using the method of Hill cipher, first we have the cipher key matrix, and then we need to find the determinant of the cipher key matrix by using covariant expansion along the first row. And we will get the formula here is A11C11 plus A12C12 plus A13C13, and then we just substitute the value of A and C accordingly, and we will get the value of determinant of A is -3. To obtain the determinant of the matrix, next we need to find the inverse of the cipher key matrix using adjoint method. So before we need to find the inverse, first we must find the cofactor matrices. So cofactor matrices is C11, C12, C13, C23, C22, C23, and C31, C32, C33. We substitute the value of C, every C there, and we will get the value of the cofactor matrix is -1, 0, -1, 0, -6, -3, -1, -3, and -1. And then we transpose it, and it stays the same because the matrix is symmetric. After we find the cofactor matrix, we can substitute it into the formula of inverse using adjoint method, but also substituting the value of determinant, and we will get the answer of A inverse is 1/3, 0, 1/3, 0, 2, 1, 1/3, 1, 1/3. In the next step, we need to back to the ciphertext matrix, which will have the letter, then we need to reassign them according to the numbers by using this table we have here. So NDXJHG VKF will be reassigned as 14, 4, 24, 10, 8, 7, 22, 11, 6. And the last step here is to compute the plaintext matrix, and then we will assign the letter after we find the matrix. So the formula for plaintext matrix is A inverse X, which is the inverse of key matrix, cipher key matrix with the ciphertext matrix. So by multiplying these two matrices, we will get the plaintext matrix, which is 12, 5, 1, 15, 27, 20, 22, 13, 8. And then we reassign the letter according to the table before, and we will get the letters here, which will be decoded as love math. And finally, we have arrived to the conclusion. So we can conclude that Telegram does indeed use cryptography in Hill cipher specifically, and as of why? Because Hill cipher fully utilizes the mathematical procedures in both encoding and decoding process by using matrices determinant and also inverse of matrix. And because it is fully mathematical, this whole process can be automatically done using computers, at the same time reducing labor costs. And the second is because the code security, in which the letters in the table that has been for both encoding and decoding process can be rearranged and randomized, giving more unique cipher key, which hard for hackers to crack. But still, even though we have these good security features, we still need to have future research to be done to prevent future hackers from cracking the code itself. Maybe because the company have the flaws within the data storage and not the cipher key itself. So this company still need to use the hackers themselves by hiring them to find the loophole within the security. That's all from me. Thank you.